Imagine you're an ambitious mechanic on a desert planet, and the order of a lifetime just dropped into your lap. You have a lucrative contract to deliver 100 shield generators. But looking around your empty garage, reality sets in. One person cannot physically assemble 100 generators before the deadline. This is where an old, wise mentor steps in with a hard truth. You can't construct a final product out of thin air. You have to gather specific economic resources first. Having eager buyers for your shield generators means nothing if you lack the raw materials and the hands to actually put them together. In economics, those required resources are called the factors of production. They break down into 4 categories: land for natural resources, labor for human effort, capital for machinery, and enterprise for the ideas tying it all together. Nobody wants a conveyor belt or a warehouse full of workers just to look at them. The need for these resources only exists because people want to buy the shield generators they make. This is called derived demand. Because of this chain reaction, when consumer appetite for a final good increases, the manufacturer's need for the workers and parts to build it scales up right alongside it. To figure out exactly what kind of labor and machinery to invest in, our mechanic needs to see how the galaxy's most successful operations make their choices. Every hiring manager and purchasing director is taking their cues directly from the final consumer. The buyer's wallet dictates the entire supply chain. We start at a bustling Rebel starship workshop. Orders for their custom fighters are surging, and the hangar is packed with mechanics working around the clock. The workshop leader pays these engineers a premium wage. She does this because their skill and training are high. They are the best in the system. Production tracks the gross number of starships leaving the hangar, while productivity focuses on the hourly output of an individual worker. Because these engineers work so efficiently, each adds massive value, directly driving up the workshop's demand to hire more. But labor isn't the only concern. The lightweight titanium they need to build the hulls is scarce. That limited availability drives up the cost of the metal, forcing the leader to hunt for alternative, cheaper materials. When you have eager buyers and a highly productive workforce, you can justify the heavy expense of running a hands-on, labor-intensive business. Now compare that to a heavily industrialized factory on a core world. Here, the floor is entirely automated, and humanoid workers are actively being fired. The factory's overlord looked at the balance sheet. The hourly wage for human laborers had climbed too high, while the purchase price of automated assembly droids had dropped. This is a textbook case of factor substitution. Producers have a choice in how they mix their resources. If capital, like these droids, achieves the exact same output as a human worker, but for less money, the producer will swap one for another. Input prices are constantly shifting. To protect their profit margins, producers will continuously substitute their resources to lock in the cheapest possible combination of machines and personnel. To predict how these decisions play out across an entire economy, we use a specific chart. This is the labor demand diagram. It plots the wage rate on the vertical y-axis against the quantity of labor demanded on the horizontal x-axis. The demand curve slopes downward to show a simple relationship. As wages drop, firms are willing to hire more workers. If the wage rate changes and all other conditions stay the exact same, we see a movement along the curve. The firm slides up or down the existing line to adjust its headcount. But if the factory owner buys cheaper substitute capital, the entire dynamic changes. The whole curve shifts to the left. The firm now demands fewer human workers at every possible wage level. Conversely, if those workers get extra training and their productivity spikes, or if consumer demand for the final product skyrockets, the entire curve shifts outward to the right. The rule to remember here is straightforward. A change in the worker's pay causes a movement along the line. A change in their productivity, the availability of substitutes, or the final product demand causes the entire curve to shift. Armed with this understanding of factor markets, our young mechanic heads back to his garage to tackle his massive shield generator contract. Instead of hiring a huge crowd of cheap, unskilled laborers, he recruits a small team of highly trained technicians to guarantee maximum productivity. And rather than blowing his budget on fully automated droids that would replace his team, he invests in specialized, high-end welding tools to help his humans work faster. By analyzing the relative costs and benefits of his inputs, he finds the exact right blend of labor and capital to deliver the generators on time and turn a profit. If you're tackling these concepts on an exam, the examiners are looking for specific vocabulary. First, always explicitly write that the demand for labor is a derived demand. Securing that term early locks in foundational marks. Second, keep your definitions precise. Never confuse production, the total sheer volume of output, with productivity, which is the efficiency of a single unit of input. Finally, watch out for the capital trap. If an exam question introduces new machinery, ask yourself, is it substitute capital, which replaces workers and shifts labor demand left? Or is it complementary capital, like tools that help workers and shifts labor demand, right? Seeing the direct link between the final consumer and the individual factory floor provides the complete picture of how an economy actually functions.